So till the last video number 2, it is 20 minutes almost. There we have completed the electrode potential, oxidation potential and reduction potential. Now we are having lecture number 3, and in this lecture we are going to discuss few things. So focus on it. So first topic is factor affecting electrode potential. Factor affecting electrode. I am not very sure about the spellings. So sometime you have to check. Concept will be 100% okay. So here first point is nature of metal and its ion. Electrode potential depends upon nature of metal and its ion. Electrode potential depends upon nature of metal and its ion. Like what? Zn plus 2, Fe plus 2, Fe plus 3. So that is the point. That means same metal but different ion. So it depends upon the metal and ions. Second point is it depends upon the concentration of ion. Concentration of ion. What concentration of ion is given? In case of gas, there is no concentration. It depends upon partial pressure. In case of gas, it depends upon partial pressure. And number 3, and important, it depends upon temperature. So these three things, these three topics, that means nature of ion, concentration of ion, partial pressure of gas, temperature. So this discussion we will discuss in Nernst equation. Different concentration. This discussion is based upon Nernst equation. So here we are not going to discuss Nernst equation. In the next video we will discuss. So what we will discuss? Today we are going to discuss about the standard condition. Standard condition. Standard condition. What are the standard condition for electrode potential? For standard condition, concentration we have to use 1 molar. Okay. In the case of gas, partial pressure of gas, it will be 1 atm or 1 bar. Number 3, temperature 298 Kelvin, 25 degrees Celsius, which is room temperature. So these are called standard electrode potential. If you are calculating electrode potential on this condition, it's called standard electrode potential. What I am saying, if you are calculating electrode potential on this condition means pressure 1 atm or 1 bar, concentration 1 molar, temperature 298 Kelvin, then it's called standard electrode potential. Electrode potential is represented by E, and standard electrode potential is represented by E naught. Okay, that is the representation. But one problem is there. What is the problem? Problem is two kinds of electrode potential we are having, oxidation and reduction. Yes or no? Yes sir. Check it. So in the case of oxidation, suppose metal tendency to get oxidized, then what happened? Electrode potential is written as Me M to M plus N. It is your oxidation potential. Standard, if you want to write, then E naught. Standard means I told you these conditions standard. That is called standard oxidation potential, SOP. In the case of reduction, children, reduction metal tendency, any X metal is there accepting an electron, so here E plus N, it is your reduction potential, and E naught, it is your standard reduction potential, SRP. So two kinds of oxidation potential, two kinds of electrode potential we are having, SRP and SOP, standard oxidation potential and standard reduction potential. So problem generated, which we have to use as a standard electrode potential. To solve this problem, IUPAC, who introduced IUPAC. IUPAC said, suppose zinc converted into Zn plus 2 electron. So here E naught Zn, E naught means standard oxidation potential is plus 0.76 volt. It is your standard oxidation potential. Suppose zinc tendency to reduce, so it is accepting 2 electron, converted into this E naught Zn plus 2 to Zn minus 0.76 volt. It's your reduction, standard reduction potential. What difference you are observing? Same value but with the minus sign. So IUPAC said that SRP, standard reduction potential, will be considered as standard electrode potential. According to IUPAC, no oxidation potential. Standard reduction potential is considered as standard electrode potential. That means reduction potential now will be electrode potential. Reduction potential will be now electrode potential. But no need to worry, if oxidation potential value given, then what you have to do? SRP, standard reduction potential, is equal to minus SOP. You have to use minus sign only. If standard oxidation potential value given, but we have to use reduction potential value, so you have to use minus sign. That's it. Hope it is clear to you. Now, what is EMF of cell? Difference between electrodes of cell. EMF is what? It is a difference between electrodes of cell. Difference between electrodes of cell. Electrode means what? Oxidation potential and reduction potential. Sorry. Electrode means cathode and anode for galvanic cell. So here, children, suppose oxidation, metal plus n electron, then E of M is equal to minus 0.2 volt, reduction X plus N except N electron, so E plus N to X, that is plus 1.8. So what is the difference in that case? Two electrodes are given, cathode and anode. So difference is 1.8 and minus 0.2, difference will be 2 volt. Difference will be 2 volt. How to calculate EMF of cell? So this upper part, EMF of cell is equal to electrode potential, oxidation potential plus reduction potential. Here oxidation where, anode, reduction where happening, lone. Remember? In that case you have to change the sign now, because we have to use only reduction potential. So minus reduction potential, anode plus reduction potential, cathode. So what happened? E reduction potential, that is cathode now, minus E reduction potential, it is anode now. So E cell, that EMF, E cell is equal to E of cathode minus E of anode. E means electrode potential. In both the cases you have to put reduction potential value, because IUPAC suggests only reduction potential value. So what formula you can use? This also direct you can use, electrode potential, E of cathode minus E of anode. Both the cases reduction potential value you have to put. So E cathode means what? Right cell, E right minus E left. Okay, but note, E cell depends upon concentration and temperature. Okay, so E cell at any temperature and any concentration we will calculate through Nernst equation. E cell at any concentration, any temperature, that we will calculate with Nernst equation, but here we are calculating at standard condition, and standard condition what? E naught of cell is what? Standard EMF of cell. It is standard EMF of cell. Standard EMF what, children? 1 molar concentration, 298 Kelvin temperature. So if you want to know, here I am erasing this. See, E cell, E naught of cell is equal to E naught of cathode minus E naught of anode. Or right or left also you can say E naught of cell is equal to E naught of right minus E naught of left. These values, this formula we will use: 25 degrees Celsius temperature, 1 atm pressure, and 1 molar concentration. That is it. So question related to this we will practice in the next video. So this is all about the concept. So in the next video we will discuss about the EMF of cell, standard EMF of cell, how to find. So thank you, children. Hope you enjoyed the video, and please share the video. Thank you.